Hello students, welcome back once again to your favorite channel Frank Guruji. In today's video, we are going to continue the last lecture of hybridization. आज के इस वीडियो में मैं आपको एक ट्रिक बताऊंगा कि वो सारे कंपाउंड जिसमें हाइड्रोजन है उसके हाइब्रिडाइजेशन को हम कैसे निकालें. साथ ही साथ you will also come to know about the organic compounds containing carbon, how to find their hybridization. So without wasting further time, let us start the video, and I expect that you continue watching the video without skipping. So let's start. How to find hybridization of compounds containing hydrogen. Okay, now boys and girls, पिछले वीडियो में जो आपने हाइब्रिडाइजेशन की टेक्निक को सीखा वो ऐसे मॉलिक्यूल्स के लिए एप्लीकेबल है जिसमें वैलेंस इलेक्ट्रॉन 9 से 56 के बीच में हो और उसमें मैक्सिमम आ जाते हैं. लेकिन अब जिनके वैलेंस इलेक्ट्रॉन 9 से कम हो, मतलब 1 से 8 के अंदर हो, उनके लिए हम क्या करें? उनके लिए यही वाला ट्रिक अप्लाई करेंगे. तो बच्चों, जैसे कि हम देखते हैं फर्स्ट एक कंपाउंड NH3, ठीक है. आई नो आपको ये पता है NH3 जो है वो अमोनिया है. तो इसके लिए आप क्या करो, सबसे पहले टोटल नंबर ऑफ वैलेंस इलेक्ट्रॉन, और उसके बाद क्या करो, सेकेंड डिवाइड द टोटल नंबर ऑफ वैलेंस इलेक्ट्रॉन बाय 8. मैं यहाँ शॉर्ट में V लिख लो, बाय 8 नहीं, आई एम सॉरी, बाय 2. 8 किसके लिए होगा? जिसमें 9 से 56 के बीच हो. सो वैलेंस इलेक्ट्रॉन between less than 9. This trick is applicable for valence electron less than 9. So we are starting with a molecule ammonia. तो ammonia में क्या है हम देखते हैं. total number of valence electron क्या है भाई? देखो, नाइट्रोजन 2,5, हाइड्रोजन में आप जानते ही हो 1 है. तो वैलेंस इलेक्ट्रॉन नाइट्रोजन में 5 प्लस यहाँ पे 3 हाइड्रोजन है 3, तो और एक हाइड्रोजन में 1. सो दिस इज 5 प्लस 3, that is 8. So in ammonia there are 8 valence electron. So this is step 1. Okay, now let's move on to step 2, that is divide total number of valence electron by 2. So that means we will divide 8 by 2, so that is equal to 4. So 4 means hybridization is sp3. Okay, अब हाइब्रिड इसमें हम लोन पेयर है कि नहीं वो भी चेक कर सकते हैं. तो देखो यहाँ पे हाइब्रिड ऑर्बिटल, शॉर्ट में मैंने लास्ट वीडियो में आपको बताया था 3 और 1 4 है, और सराउंडिंग एटम कितने हैं? सराउंडिंग एटम 3 है. तो भाई लोन पेयर जो है उसको हम लोग कैसे निकालते हैं? लोन पेयर मैं शॉर्ट में LP लिख रहा हूँ, LP. सो दिस इज इक्वल टू हाइब्रिड ऑर्बिटल माइनस सराउंडिंग एटम. सो दैट इज 4 माइनस 3. इसका मतलब अमोनिया में जो है नंबर ऑफ लोन पेयर्स 1 है. तो टोटल हाइब्रिड ऑर्बिटल 4 में से क्या हो गया? 3 बॉन्ड पेयर्स और 1 लोन पेयर. तो आप जानते ही हो अमोनिया का स्ट्रक्चर कुछ ऐसे होता है, यहाँ H and this H और यहाँ पे एक लोन पेयर. So in this way we can find the hybridization, we can also find the lone pairs and also the structure. So in this technique, what you are doing, those compounds which are having hydrogen in them, you have to count the total number of valence electron and then divide it by 2. Now let's move on to the next molecule. Ammonium ion. Next molecule I would take is that of ammonium ion. Okay, number 2, NH4 plus. So let's see if it's visible to you or not. Total, I'm using a green pen, total number of valence electron is equal to how much? Nitrogen 5 प्लस 4 हाइड्रोजन, और एक चीज़ यहाँ पे जो है आप देख रहे हो माइनस प्लस है, प्लस मतलब जितने प्लस है आपको उतने माइनस करने हैं. सो दिस इज इक्वल टू 5 + 4 9, 9 - 1 that is 8. So total number of valence electron, so what we have to do, that is total number of valence electron divide by 2, that is 8 by 2, so that is 4. So this implies hybridization of ammonia is also 4. Now is there any lone pair? So lone pair, what? Hybrid orbital 4 and surrounding atom 4, 4 minus 4 0, so no lone pair on ammonium ion. So that is the second molecule. Now let's move on to the third molecule, water. It's very simple trick, just calculate. Now I'll directly do it. So total number of valence electron is equal to 2 plus 6 divide by 2. So that is equal to 8 by 2, that means 4. So 4 means sp3. So again we can say hybrid orbital, how many? It is 4. Now surrounding atom 2. So that means lone pair is equal to hybrid orbital minus surrounding atom, so that is equal to 4 minus 2, that's why 2. So in water we see there 2 bond pair plus 2 lone pair, and if you remember the structure of water is something like this. Here is one lone pair, another here, and it's an angular molecule. So this is the third molecule. Now we will move on to the next one, that is H2S. It's again same, no difference. H2S, same thing, total valence 2 plus 6, 8 by 2, sp3 same. Okay, now we will move on to number 4. We have done NH3, NH4 plus, H2O, H2S. Number 5, what it is, we will take EH3 and try to find out how many valence electron it has and all, and then divide it. See, in phosphorus means 285, so it has 5 valence electrons, so 5, and there are 3 hydrogens, so 3 into 1 divided by 2, you get 5 plus 3 by 2, so 8 by 2, that is equal to 4. This means sp3. So hybrid orbital 3 plus 1 4, surrounding atom 3, lone pair 4 minus 3, that is equal to 1. So out of 4, 3 bond pair plus 1 lone pair. So on this basis we can find the structure too. Now next move on to the sixth molecule, that is H3O plus. Okay, so H3O plus means hydronium ion. You must be knowing this. Hydronium ion, total number of valence electron divided by 2. So hydrogen 3 plus oxygen 6, 3 into 1 plus 6. Now जितने प्लस उतने माइनस, तो यहाँ पे हमें 1 माइनस करना है. सो दिस इज इक्वल टू 3 plus 6 minus 1 by 2, that is 9 minus 1 by 2, that is 8 by 2, that is 4. So that means hybridization of HCO plus is also sp3. Now does it have any lone pair? Let's check out. So 4 and minus 3, that is 1. It has one lone pair. So 3 bond pair and 1 lone pair. Next, let's move on to the last molecule containing hydrogen, that is NH2 minus. Okay, so here also total number of valence electron by 2. You already know nitrogen means 5, hydrogen 2 into 1, and one thing, जितने माइनस है उतने ऐड करना है. सो प्लस 1 डिवाइडेड बाई 2, सो 5 प्लस 2 प्लस 1 बाई 2, that is 5 plus 2 plus 7 plus 1 8 by 2, that is equal to 4. So 4 means this is also sp3 hybridized. Now does it have any lone pair? So 4 minus 2, yes, it has 2 lone pairs. So in this way we can calculate the hybridization of compounds containing hydrogen. So I hope you have understood. Please note down, and then we will learn about the method to find out hybridization of organic compounds containing carbon. Now let's move on to the organic compounds which contains carbon atom, and let us know the method how to find the hybridization of the carbon atom present in the organic compound. Now here I would say that for count, the method is count only the sigma bonds, count only the total number of sigma bonds, and assign according to that, and assign hybridization according to that. मतलब क्या है, आप जस्ट देखो कि कंपाउंड में कितने सिग्मा बॉन्ड्स हैं और उस हिसाब से फिर आप हाइब्रिडाइजेशन असाइन कर दो. जैसे कि मान लो मीथेन, दिस इज मीथेन. नाउ द स्ट्रक्चर ऑफ मीथेन इज समथिंग लाइक दिस. वी कैन राइट इट. Now how many sigma bonds are there? You should know that sigma bonds means the bonds present in the single bonds. This is sigma bond, this is sigma bond, this is sigma bond, and this is their sigma form. So there are 4 sigma bonds. So 4, because it is 4, so the hybridization is sp3. So the hybridization of carbon in this is sp3. Now let's move on to ethane, C2H6. You should know the structure. You must have learned in your previous class. So see here, then all these are sigma bonds because they are single bonds. So there are 2 carbon 1, carbon 2. This first carbon 1 2 3 4 sigma bonds, so this is sp3 hybridized. Similarly you count here 1 2 3 4 sigma bonds. So this one is also sp3 hybridized. So that means this carbon as well as this carbon both are sp3 hybridized. So how to find out the hybridization of such molecules? Just by counting the number of sigma bonds. Now let's see another molecule like one containing double or triple bond. See here, let us draw the structure of ethene, C2H4. So you should know ethene has double bond. So this is the structure of ethene. So one sigma, these are the sigma bonds. Now in case of double bonds, you should know that if a double bond is present in a molecule, then Out of the two bonds, one is a sigma bond and the other is a pi bond. So this is a sigma bond and this is a pi bond. We are not required to count this. We will just count these bonds, sigma, sigma, sigma for this first carbon and then on the second carbon, C1, let's write C2. So the first carbon, 1, 2, 3, it has 3 sigma bonds. So hybridization is sp2. Similarly, you count here also 1, 2, 3. 3 sigma bonds. So this is also sp2 hybridized. So in this way, you can find the hybridization of ethene. Let's see ethine, C2H2. Here there is a triple bond, you know, and 2 are. So single bond, always sigma bond. Now out of the triple bond, 1 is sigma and the rest 2 are pi. And in this method, this is suppose C1, this is C2, carbon 2. So in carbon 1, we see that 1 sigma here, 1 sigma here. So this is sp hybridized. Similarly, you see here 1 sigma here, 1 sigma here. This is also sp2 hybridized. So in this way, we will find the hybridization of such molecules. Let's move on to some more difficult ones like this. Suppose the molecule is this CH2 double bond C double bond CH2. So in this way, what you have to do, you just open the bonds. Okay, now you calculate. Here is 1 sigma, here is 1 sigma, 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 pi, sigma, pi, sigma, sigma. So we are having 1 carbon here, 1 carbon 1, carbon 2, carbon 3. So let's see how many sigma bonds does carbon 1 has. 1, 2 and 3. So it is 3 means sp2. Come to here, this is 1 sigma this side, 1. So 2, so this is sp hybridized. And the third one, 1, 2, 3. So this is sp2 hybridized. So the 3 carbon atoms present in this molecule is, one is sp2, another is CSP, and the third one is sp2. Next, let us move on to another example like acetaldehyde और इथेनॉल. एसिटाल्डिहाइड जिसे हम लोग इथेनॉल भी बोलते हैं. तो इथेनॉल क्या है भाई? ये है आपका CH3CHO. इसको कैसे लिखेंगे? इसको आप ऐसे लिख दो, C डबल बॉन्ड O H CH3 और फिर सिग्मा बॉन्ड्स गिन लो. सिग्मा 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 पाई. तो इस कार्बन में 1 2 3 4 सिग्मा है, मतलब ये sp3 हाइब्रिडाइज्ड है. अब आप इस कार्बन में आ जाओ, 1 2 3, मतलब ये sp2 हाइब्रिडाइज्ड है. ओके, आप फॉर्मेल्डिहाइड का बना लो खुद से. फॉर्मेल्डिहाइड मतलब मिथेनॉल, HCHO होता है, simple H C double bond O H. This is the structure, you find out yourself. Now let's move on to acetone or propanone. Acetone or propanone. तो हेयर एसीटोन मतलब CH3CO CH3. कुछ नहीं करना है, C डबल बॉन्ड O C, हाइड्रोजन को खोल के लिख दो आप और जस्ट सिग्मा बॉन्ड्स को गिन लो. तो यहाँ पे आप देखो, सिग्मा 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 सिग्मा, 1 sigma 1 pi. We are least interested in pi. In this we are seeing 1 2 3 4, that is sp3. Come to this 1 2 3 sp2. come to this carbon, 1 2 3 4, so sp3. So this is the way you will calculate the hybridization of the carbon atoms present in this molecule. Next, let us move on to ethanoic acid or acetic acid. Acetic acid or acetic acid or ethanoic acid. Simple formula, CH3COOH is the formula of this ethanoic acid. तो क्या करना है, सिंपल आप इसको खोल के लिख लो, H. So we are having sigma, 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 pi, sigma, sigma. We are not interested in pi. So here in this carbon 1 2 3 4, so sp3, in this 1 2 3, that is sp2. We are not bothered about oxygen. So in this way we can find the hybridization of the carbon. You try it for formic acid, that is HCOH. Okay, and the last I would say is that HCN, hydrocyanic acid. Sometimes they are writing methyl cyanide, HCN. तो ये HCN जो है बच्चों, इसको क्या करना है, HC ट्रिपल बॉन्ड है यहाँ पे, तो ये सिग्मा है, ये सिग्मा है, ये दोनों पाई होता है, तो आपको सिर्फ सिग्मा गिनना है, यहाँ पे एक सिग्मा, यहाँ पे एक सिग्मा, 2 है, मतलब sp, this carbon is sp hybridized. And last but not the least, I would give the example of benzene. बेंजीन, देखो भाई बेंजीन क्या है, ये है बेंजीन का स्ट्रक्चर, ऑल्टरनेट डबल एंड सिंगल बॉन्ड्स होते हैं, यहाँ पे H, 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 यहाँ पे H. तो हर सिग्मा बॉन्ड सिग्मा 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 सिग्मा, हम मैं सिर्फ यहाँ पे सिग्मा ही हमें काउंट करना है, सिग्मा 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 सिग्मा, एंड दीज आर पाई बॉन्ड्स. तो यहाँ पे जितने भी, यहाँ पे 6 कार्बन है, देयर आर 6 कार्बन, कार्बन 1 2 3 4 5 6. So let's start here, 1 2 3. So that means this is sp2 hybridized. So when we will count, we will see that all the carbon atoms are sp2 hybridized because they will have 1 2 3 sigma bonds. So please remember, all the carbon atoms are sp2 hybridized. So a very simple trick. I hope you have understood the trick and would be able to find out whichever question comes in front of you. It's the easiest and the simplest trick. So go through it. If you like the video, please push the like icon and also share my video and ask your friends to subscribe my channel. So until the next video, it's all the best.